If we start with any number like 99, take the square root of it, then take the square root of that, and then take the square root of that, and keep going. As we keep going forever, that is going to approach 1. So if we start with 99 and keep taking the square root, it's going to approach 1 pretty quickly. And if we keep hitting the square root, it's going to eventually say 1 because the calculator rounds and it says 1. So anytime you take the square root of a number greater than 1, it's going to keep dropping down until it gets to 1. But this is also true if the number is between 0 and 1, it's going to go up until it hits 1. For example, 0.2, if we keep taking the square root of it, notice how it's increasing and it's going to approach 1. And if we hit it enough, it will actually say 1. Because of the fact it rounds. And there's the 1. This is also true for negative numbers and imaginary numbers. They will all approach 1 as you keep taking square roots. The only number that won't is 0. That's because the square root of 0 is 0, and as you keep taking square roots, it's just going to keep being 0. One issue with some calculators, if we plug in -5 and take the square root, it just says error. But it does actually approach 1. This calculator just isn't designed for imaginary numbers. So let's talk about why all these different numbers approach 1. Here are some properties of exponents that we're going to use. I've made videos about each of these. If you don't understand any of these exponent properties, just comment below which one, and I'll try to at you in my video that goes over it. So since we're trying to cover all different types of numbers, we're just going to call it the square root of x. Now this square root has an index of 2, and it's to the power of 1. So using this bottom property, we're going to rewrite it as x to the 1/2. Now if we take the square root of that square root, that's going to be like taking the 1/2 to the 1/2 power. And using this property, that's going to give us x to the 1/4. And then we can take the square root again, and that's going to give us x to the 1/8. If we do it again, that's x to the 1/16. We can do it again, and that's x to the 1/32. And as we keep doing it, this exponent is going to get smaller and smaller. It's going to approach 0. There's a way to write out this expression. We would say x to the power of 1/2, and every one of these 1/2s is a square root. We're going to take this 1/2 n times, so that would end up being n square roots. But we want to take it an infinite number of times, so we're going to take the limit as this n approaches infinity. So you can see here what's happening. Because the square root is the same thing as a 1/2 exponent, as we keep doing 1/2s, we're going to keep getting closer and closer to x to the 0. And since x to the 0 is equal to 1, that's the reason why all numbers you keep taking the square root of are going to approach 1. And then this is true for everything except x equals 0. You guys are awesome. Comment on what you'd like me to talk about next, and I'll talk to you soon.